Alrighty, going once, going twice. All right, cool. So I guess we will skip that. So now onto some review. This is going to be kind of an open-ended review. I want to take a poll in the chat to see if there are any topics or specific questions that people feel like they want to review or just get a better explanation of from last week. So you can just start listing topics in there, and I'll go through them and just kind of start to do some demo code and explanation, and I can take any further questions from there. Default and guard operators. All right, cool. So while we're waiting on other questions, I'll go ahead and jump into Kevin's. Let me share my screen. All right, so first off, we'll talk about the default operator. This is a special use case for the OR operator, which is, again, the double pipes. So let's say that we had a variable called x that we were going to run in a script. And we are going to assign x to equal x if there is already a value for x. So the idea is that if x has been previously assigned somewhere else in the program before we've made it to this line, then we're just going to set x to whatever it is currently. However, if x has not already been assigned, then we will default to assigning it to whatever is on the right side of the OR operator. So in this case, it would be 11. So maybe we're doing some math with variable x and variable y. Say after the line, we console log x plus y. If x didn't already have a value and we tried to add x plus y, let's see. I guess first off, if x had been declared as a variable before, we would get the error message, not a number. Let me make sure that's right. I'm going to run it down here. Yeah, not a number, because right now x is undefined, and we're trying to do a mathematical operation with a variable that is undefined. Anytime you try to perform a mathematical operation using something that's either A, not a number, or B, it's a mathematical operation that a computer doesn't know how to handle, which you can sometimes run into when you're working with, there's a maximum positive and a maximum negative number that any JavaScript engine knows how to handle. It differs from engine to engine. But in this case, we would get not a number. Now, if we hadn't declared that variable beforehand, then I believe that would give us a reference error, because it goes to look for this variable x, but it doesn't find a variable x anywhere in memory. So what we do is create a default so that when it gets down to x, it creates the variable x. It goes to assign it. It first tries to assign it to x, and because it can't find a value for x anywhere else, and this is an undefined value, so it equates to falsy. And the way the OR operator works, when it sees a falsy value on the left-hand side, it jumps to the right-hand side to see if it can find a truthy value. In the case of the default operator, I believe it works a little bit differently, because usually if you were trying to get a truthy or falsy value out of this, like if we were saying if 0 or 11, then do some code. in this case, the interpreter would say if, and then it would look at the expression on the left-hand side of the OR operator, and it would take that 0 as a falsy value. And so it would jump to the right-hand side, and then it would see the 11, and the 11 would be a truthy value. So it would go ahead and execute line 6. In the case of the default operator, I believe that it's going to go ahead and assign x to the 0. And I believe that that will be the case as long as the value here is neither undefined nor a reference error like we saw before. But I'm going to run it just to make sure I'm right about that. Okay, so no, I'm wrong about that. If there's a falsy value here, then it's automatically going to assign it to the right-hand side. So even though we have 0 here, because that's falsy, it automatically assigns x to 11. So before I move on to the guard operator, are there any questions about the default operator? All right, cool. So I'll move on to the guard operator. 1 second, I'm going to grab some example code. All right, so the guard operator is a way of using the AND operator to make sure that 2 conditions are true. All right, so the way that this is going to work, actually, let's see. I'm going to get rid of this. For username equals. All right, so let's imagine that we have a program where a user might log in. If they haven't logged in yet and this variable equates to false, then then get username is just going to be assigned to false. However, if this first one equates to true, then it will look at the right-hand side, and as long as this is a truthy value, get username is going to be assigned to username on the other side. So let's try that out. All right, so when the interpreter gets to this, it's going to declare this variable get username, and it's going to set it equal to, and it's going to see an expression true and have that truthy value. But then when it sees the guard operator, it will go to the other side to look for another truthy value. And again, any string except for an empty string is going to be truthy. So it's going to assign get username to Zan. Cool. I'm actually curious if I assign this to an empty string, if it will log false. All right, so it does log the empty string. Okay, so I guess let me revise what I said before. The right-hand side doesn't have to be a truthy value. Only the left-hand side does. And if the left-hand side is truthy, then the interpreter is going to assign get username to whatever is on the right-hand side. Are there any questions about that? Yeah, no problem. Cool. Well, are there any other questions besides about the default and guard operator? How about nested while loops? Do you have any specific questions about nested while loops? Let's see. Try to construct some example code for this. But if you do have a specific question or like a specific example that you want to clarify, let me know. I'm not really, I can construct some kind of nested while loop, so. Alrighty. I'll look for that exercise as well. So let's find nested while loops in the curriculum. All right. In numbers are coming to a number party. Introduce them to each and all the guests as they arrive. You should end up with the output looking something like this one for n equals 5. All right. Let's see, we have n equals 5, and while I is less than n, j equals 0, while j is less than n, console log I is I, and j is j, j++. All right, so I think, trying to think of the best way to demonstrate this. I think that it will be helpful to kind of walk through what's happening at each line of the execution to understand how this is working. So the, oops. Cool. So I guess what happens in this code is I is 0, and then each time it enters, j, this is going to increment as starting from 0 up to n. So this will log this out 5 times for every value of I. And then we want to construct. Okay. Let's change this a little bit. Welcome. Huh. I think, to me, it seems like we'll have an inner loop that will be, we'll have only one inner loop that will be solely concatenating a string. Does anyone have any solutions that they want to share for this exercise? Yeah, sure thing, Patrick. Let's see. Do you want to, can you copy and paste your code into the chat, and then I'll put it into here? Thank you. Oh, oh no, that didn't work. All right, 1 second. That's okay. So let's see what happens. We declare a variable I and set it equal to 1. We declare a variable j that's not set equal to anything yet. And we have our n set equal to 5. We start off with an empty string greeting set equal to this empty string. And while I is less than or equal to n, greeting equals welcome plus I, and we reassign j equal to 1. While j is less than I, if j is equal to 1, greeting plus, so we add meet, we add what we already have in greeting to meet plus the current value of j. Else if j is less than I minus 1, so let's see, what would happen the first time through? I is equal to 1, so greeting is equal to welcome 1. And then we set j equal to 1, and the first time through, it's going to add and reassign greeting to be welcome 1, meet 1. And then we increment j up so that the second time it gets to this else if loop. If j is, let's see, less than I minus 1, and I is 1 right now, so that's not the case. So greeting gets reassigned to welcome 1, meet 1, and 2. And then we increment j one more time. So now j is, oh, let's see. It wouldn't have actually made it that far because j wouldn't have been, the second time around, j wouldn't have been less than I. So we'd actually exit that inner while loop. And then it looks like it would console log greeting, yeah, welcome 1. And then we would increment I. So now I would be equal to 2. And so now it would make it down to that second one. Two. And then that's what would get console logged out this time. And then when I was equal to 3, it would say, I'm sorry, the second time it would have been welcome to meet 1 and 2. And now this time I's 3, so it's going to say welcome 3, meet 1. And then when J is 2, that's still, or let's see, J is 2. That's still not true, so it's going to say meet 1 and 2. And then the next time around, it would say, and wait, meet 1 and 2. All right, and so now when I is 4, it's going to say, welcome 4, meet 1. And the next time around, this else if would equate to true. So it would say, welcome 4, meet 1, 2. And then the next time around, when J was 3 and I is 4, it would jump down to the else block and become welcome 2, meet 1, 2, and I'm sorry, welcome 4, meet 1, 2, and 3. And then that's what would get logged out. And then I might actually, I think I'm going to stop there instead of continuing through the entire execution. But let's see, I believe, Kevin, does that make more sense now? Cool. All right. So I think if we have any more questions, I'll take one more question. And I can do a little bit more review tomorrow, but I do want to dive into functions before I don't want to spend too much time on review today. But if there are any other questions, I can take one more question. All righty, cool. Well, in that case, I will go ahead and jump into functions. All right, so functions, what are functions? You probably encountered some version of functions either in the curriculum app or in the test suite. They're essentially a way of wrapping code so that you can use that code later on in your program and so that you can possibly use it multiple times without having to rewrite all of it. And I'm actually going to, before we dive into the lecture, I'm actually going to show you a little bit of what a function looks like. So this would be a function, and this function is just going to log out hello world. Oh, so that is what the function will do. It will log out hello world. This is the definition of the function. So essentially what we're doing right here is creating a variable called hello world. And behind the scenes, hello world has this code attached to it. Now, when we define the function, nothing happens. The code inside the function doesn't run, and it won't run until we actually invoke that function. And the way that you invoke a function is by putting parentheses after it. And then as with any JavaScript statement, you finish it with a semicolon. So now that we have our variable named hello world and we add the parentheses, this is actually going to invoke the function. Cool. So now we see hello world. All right. What is a function? Does a function need a terminating semicolon after? You're right. This particular way of writing a function doesn't. There are two ways of writing a function, Patrick. One called a function declaration and one called a function expression. And I'll get into the difference between the two in just a minute. So what is a function? It is a data type in JavaScript. Function is an object. That's the kind of data type that it is. It's a function, obviously. It has a name property. So the name that we attached that last function to was hello world. It stores code inside of it. Suppose we have this function hello world. The first thing the JS interpreter finds in our function declaration is our function declaration. It then creates a place in memory for the function. So it opens up this space in memory where we're going to store something called hello world. It will then see that we have named our function hello world. It stores this name as a string on the function's name property. It then checks for parameters, and we'll get into what parameters are in a second. But right now, we haven't supplied any parameters. The parameters would be between the parentheses, but this particular function doesn't have any. After finding no parameters, the interpreter moves on to the code block we have defined. It stores that code in the function. Now, just to be clear, there isn't actually a code property that you can access on the function. It's just important that this code is stored behind the scenes inside of the function object. All right, so we're going to go ahead and call that function or invoke it. So it searches through memory for a function with a matching name property. Because we put the pair of parentheses after the function name, we are telling the interpreter to invoke the function, so to run the code that's stored in that function name. It then creates an execution context in the stack. So every time you invoke a function, it creates a separate context. So I could actually invoke hello world multiple times, and each of those multiple times would have a separate execution context. The execution context is then bound to the function on the function's scope property. It then adds the code stored in the function to the execution context. So it creates this context where this particular instance of the function is going to run, and then it adds all the code from that function into the context. It then runs that code. And in the case of hello world, it can run this code and not have to look anywhere else for anything else. There's no variables in here. It just logs out the string hello world, which is hard-coded into the function. And so we see hello world is logged onto the console. Because there is no code left to run, our execution context, in the execution context, the interpreter tells what's called the garbage collector. So this is a process that runs behind the scenes called garbage collection. And the interpreter tells the garbage collector that it can go and remove that particular execution context from memory and from the stack. The next time we run this function, a brand new execution context will be created, and the same process will occur. All right, so before I go further, I'm going to look at the questions in the chat. Is writing a function like var hello world equal to function versus function hello world? Or do they serve different purposes with more advanced functions? Yeah, so I guess I'm going to go ahead and jump into the difference between a function declaration and a function expression. So what you see here is a function declaration. And then this would be a function expression. Now, either of these are appropriate, and they're going to store the function in the same way. You'll notice that I did add the semicolon down here. It's necessary when you do a function expression versus it's not necessary when you do a function declaration. So just to kind of, at a very molecular level, let's break down the syntax. With a function declaration, you say function, and that signals to the interpreter that we're about to have a function. And then we give it a name, hello world. It looks for the parameters between parentheses, and then everything between the curly braces is a code that's going to run when we call that function. With a function expression, we actually begin with a variable declaration. Let's see, if you remember from last week, this is a variable declaration, and then when we actually assign it to something, this would be a variable expression. So with the function expression, we declare a variable, and this is our variable hello world is going to point to this function. And so then we assign the variable hello world to this function that we're creating. Now, behind the scenes, we're creating a function that doesn't actually have that name property. Rather, again, this is a data type, so it's a value that's held somewhere in memory, and we've created a variable called hello world that points to that function value. So I guess Hack Reactor advises people to use this syntax, the function expression. Out in the world in general, you'll see people using either or, and it's really a stylistic preference. There are some differences in the way that these are interpreted by our interpreter when the JavaScript, so JavaScript gets compiled before it actually gets run in the browser, which means our script gets rearranged and then is actually executed. And there's a process called hoisting. So Andrew, to answer your question, there are some differences between these two. But I'm going to wait to get into those, just because I think it's important to understand the basics of functions before you get into slightly more subtle concepts of the differences. For the purposes of the exercises today, you can use either of these. All right, so back to our hello world function. Let's pretend we forget to invoke the function by leaving the parentheses off. So you'll notice we say hello world with no parentheses. The interpreter would first see the value of hello world, and it would look through memory to find a function called hello world. If it didn't find it, it would start looking for variables with the same name. However, in this case, we have a function. Because we did not invoke the function in the the interpreter will simply return the body of the function to us. It will not create an execution context bound to the function scope. So let's take a look at that. I have a browser window. One second. I'll show you why I want a browser window. If we don't invoke hello world, so if we just said hello world, if I try to console log this out without invoking it, if I do that in Sublime, it's just going to say function hello world. It's going to do the same thing. It's actually doing the same thing behind the scenes in the browser, but it's going to show us a little bit more detail about this function object if we do that here. Cool. So you'll notice that when I run the same code and I console log it, it actually console logs out the whole function body because that's what it sees behind the scenes. It also logs out an undefined property, and that's another interesting piece of functions that we'll get to in just a few minutes. All right, so because we didn't invoke hello world, it doesn't create an execution context and nothing happens. All right, so now we're going to get into parameters and arguments. Suppose we have a function called greeter. So let's jump back over here, and I'm going to create this function called greeter. When we actually define the function, these two variables, name and surname, are called parameters. So when we're talking about the function definition, we're talking about parameters. When we want to actually call this function greeter, we're going to pass it what are called arguments. Behind the scenes, those parameters are going to get replaced with our arguments. So let's see. I'm going to pass the arguments Douglas Crockford. For those of you who don't know, Douglas Crockford is a JavaScript advocate, pioneer, made JavaScript popular. Cool. So our greeter function will log out, hello, Douglas Crockford. So what's happening behind the scenes is that we're creating variables that exist only inside this function, where we're creating a variable name and a variable called surname. And when we call that function with arguments, we're saying that name equals Douglas Crockford and surname, or I'm sorry, name equals Douglas and surname equals Crockford. So that when, in this particular execution context, when console log is run and the computer goes to find the value of name, it sees that the current value of name in that context is Douglas. And the current value of surname is Crockford. All right, so let's jump back to the slides to find out a little bit more about that. All right, so we have our greeter function. The first thing that would happen is that the interpreter would see, oh, sorry about that. The interpreter would see our function declaration and create a place in memory for our function object. The next thing that would happen is that the interpreter would see the name we have supplied to our function, and it would then assign the supplied name to the function's name property. The interpreter would then check the parenthesis following the name for parameters. In this case, we have supplied two parameters, name and surname. The interpreter then stores these in the function's constructor, which is so the name property is also technically stored in the constructor. And this is a function behind the scenes that's actually building the function that we're building right now. It's also important to note that the function's constructor also has an arguments property that will remain a null value until we call the function. So each time we call a function, there's this property called the arguments object, and however many arguments we pass in, that arguments object gets filled up with those arguments. At this point, the interpreter looks at our code in our code block and adds it to the function stored in memory. Let's call it and see what happens. So we are supplying two arguments to our function call. In this example, they are string values, but they can be of any of the data types that we've encountered so far. So we could give it another function, we could give it an array, we could give it an object, which are two other data types we'll be going over this week. Side note, does anyone know is this Cloud Strife? Is this a reference? Is this like a video game reference? I didn't make this particular set of slides, so I was just curious. Final Fantasy, yeah. All right, when we first call the function, the interpreter will search through memory for a function with the same name. It will then invoke the function, and it will passed our two strings as arguments. The interpreter will then add our arguments to the arguments object in the constructor, right here. Next, it will create an execution context and bind it to the function's scope. Then it will add the code to the execution context, and then it will run the code. While it is executing the call to console log, it will find the value name. This works very similarly to a variable lookup. It will first search within the execution context, so within our current execution context, for a function or variable called name. When it doesn't find it, it will look into the function constructor to see if there is a parameter that matches the value. If there is, it will look in the arguments object in the same index. So you'll notice that name is the first parameter, so it's going to look at the arguments object for the first element there. It will look in the arguments object for the element in the same index. It will then see the that name is referencing the 0th value in the arguments object. So we call the first element the 0th index. It goes 0, 1. If we had more, there would be 2, 3, 4. It will then add that value to the execution context. So now it's gone down and replaced our name value with cloud. And that's now that value in the execution context. It will then go through the same process with surname. It will look at the execution context to see if we've defined a surname variable inside of the execution context. And when we haven't, it's going to look at the constructor for the surname variable and then replace that variable with the value at that position in arguments. It will see the surname parameter is in the first index, and it will look up the first index for a corresponding value and put it in the execution context. All right, so at this point, the function is done executing, and what we have concatenated will be logged to the console. And then the garbage collector is going to come around, and it's going to get rid of the execution context. And at this point, the scope is no longer pointing to an execution context. Because it has no context, it no longer needs arguments, so those are set back to null. And now we're back to square one, and the function is ready to be called again at any time. All right, so besides say that's a wrap, I want to a little bit more in depth about how this idea of scope works. So each time we call this function, it has its own scope. So what is scope? Let's say that we set a variable called name out here. And also a variable called surname out here in what's called the global scope. So a scope is a way of kind of walling off values inside of your program so that you can have different instances of variables. So for instance, right now in the global scope, our top level scope, we have variables called name and surname. But when we go inside of our function, the greeter function, those variables take on a different value. Those variables now point to the parameters of that function. This is inside the function scope. So each function creates a new scope where we can have new instances of variables. That said, let's say that we actually didn't give this function greeter any parameters. We could still call greeter. And what would happen is that when the interpreter got to those variables, it would look inside of the function scope for those variables. It wouldn't find them there, so it would look up to the function's constructor for those variables. Because there's no parameters, it wouldn't find them there. And so it would jump up to the next scope above it, which in this case is the global scope, and would see, oh, there's actually some other variables called name and surname, and it would then replace those variables with the name and surname that we had already defined. So that would log out, hello, Bob Smith. And also currently, let's say that we tried to run greeter by passing it some arguments. Because we don't have any parameters defined, function is going to have access to the arguments Douglas and Crockford, but it's not going to know what to do with them. So it's still just going to default up to our variables named name and surname. Now, when we add those parameters back in there, again, when it gets to these, on line 11, when it starts to execute, it gets to this point in the function, and it looks for the name variable in the function's scope. And because it finds it in the function scope, it never goes up to the global scope to look for it. All right, so I'm going to keep going a little bit further in depth with that, but before I do, I know that was a lot of material, so I want to go ahead and take some questions about parameters and arguments and scope. All right. When perusing the interwebs for JavaScript help, I frequently come across warnings to not use global scope for variables, but create an independent scope for all variables used in your code. So I wouldn't worry about that yet, Patrick. That is a good point when you actually move into making production code, because if you do have variables floating around in the global scope when you have a program that's out online, any user of your code of your application would be able to like console log the window object. Actually, I don't know if it'll log anything here. Okay, so we do have a window object, and those variables would be attached to the window object. And if those variables are something important to your program or something that gives a user insight into how your program works, it's going to be potentially a security vulnerability. That said, again, don't worry about it while you're learning how to use it. That's something that really doesn't matter until you get to writing production level code. Cool. So the arguments are passed as variables. The arguments are passed as variables. Well, so technically they get stored in the arguments object. And behind the scene, the arguments object operates like an array. It's actually called an array-like object. And I'll log out arguments right now. For those of you who haven't encountered arrays or objects before, don't worry about understanding this. It'll make more sense by the end of the week. But this is what the arguments object looks like. It's an object, but the keys, each of the keys on the object are numbered like an array. So what happens is that when we call the greeter function, it looks at so it goes to execute line 7. It looks at the function's constructor for a name variable. And because name is the first parameter that's defined in our greeter function, it looks at the value in the arguments object at the 0th index. And that's how it reassigns this name variable behind the scenes to be equal to whatever the first element in the arguments object is. So that's how that works. Does that make sense, Vincent? Cool. Yeah, that's a pretty detailed understanding of how that works. I would say that most people using JavaScript don't understand all of those mechanics. It's really just important to know how to pass arguments into a function, and then eventually it will become important to be able to access different elements of an arguments object. But even that, not really important yet. If the parameters are in the function, but the arguments aren't stated when declaring the function, with the example on your screen, use var name surname instead. So parameters. Oh, I see what you're saying. So you mean if I call greeter without any arguments? Is that what you mean, Kevin? Cool. Let's try that out. Let's see what happens. Hello, undefined, undefined. So what's happening behind the scenes is that we're still declaring these name and surname variables in the scope of our greeter function, but we just never give them a value. So you actually have two places in memory where those variables are. We have a separate space in memory for the scope of the greeter function. But in that scope, we have not assigned those variables to anything, so they're currently pointing at undefined spaces in memory. Is the scope only used when describing one individual function, or can it also be used to describe the entire program? Good question. It can be used to describe the entire program. So right now we have the global scope would be the top level before we enter this function. And one good analogy that I've heard used, analogy, metaphor, I'm not sure which one it is, to talk about the greeter function, or to talk about function scope, is to think of it like a walled garden where the door only opens, let's see, the door only opens in, it doesn't open out. So for instance, if inside the greeter function, I said var name equals Douglas, and then I call greeter, and then I tried to console log out name. Does anybody want to guess what name is going to log out right here? Yeah, it'll be undefined. Or it's even worse, it's going to be a reference error, because in this global scope, out here outside of the function, name has not been created. And so there's no space in memory that exists in the global scope that has a name variable. If we declared a name variable, and then we ran that, it would be equal to undefined. Because essentially this outer scope outside the function, it doesn't see line 5 being run. Now, that's because we've created a separate instance of the variable name inside the function. On the other hand, if we could reassign name inside a function, if instead of creating a new variable, we just said name equals Douglas. So what's happening here is that when we actually execute greeter, it gets to line 5, and it sees this variable name. And so it goes to look, before it gets to assigning it, it goes to look for a variable name in memory. It doesn't find the variable name anywhere in the function scope. So it jumps up to the global scope and says, oh, we do have this variable name. So I'm going to use this variable, and I'm going to assign it to the string Douglas. So now this variable name is pointing to the string Douglas. And so we console log out Douglas, as we would expect on line 11. Let's see. We're going back to talking about individual scopes versus program scope. So even inside of functions, we can make a function called inner. We can have scopes within scopes. So this function actually has let's see. That inner function has its own scope that's walled off from the outer function. How am I going to demonstrate that? Let's do this. Let's say var name, and then we'll console log name as part of greeter. And once again, if we use the var keyword, we're creating another instance of name inside of this inner function. And so when we run greeter, it's still going to log out as undefined because it doesn't. One second. I'll also have to execute the inner function for anything to happen. So yeah, still logs out undefined. However, if we remove that var keyword, it would now log out Douglas again, because in the inner function, when it executes, it goes to look for the name variable, and it finds it in the next scope up. And so then it reassigns this variable and logs it out on line 11. And similarly, we can move that even further out. For now, when we execute this inner function, it looks for a name variable. It doesn't find it in its own function scope. So it falls back to the next function scope. It doesn't find it there. So it goes all the way up to our global scope, and it does find it there. So it goes ahead and reassigns it. Alrighty. Are there any other questions? Alrighty. So I'm going to have us go ahead and break off into pairs like we usually do. I've cleared out the current pairs list. So go ahead and get on Slack and arrange new pairs. And once again, whenever you pair with someone, mark it on the pairs checklist so that we can shoot to for everyone to pair with everyone else throughout the class. And I do, before you go off on the exercises today, I do want to say that like this area, functions and scope and arguments, this is a kind of like the meat and potatoes of JavaScript. This is really one of the way that functions work in JavaScript is one of the reasons why it's such a compelling and useful language. That said, it's also one of the hardest concepts to master, or it's kind of a big area. And that's why we're actually going to have another 2 or 3 days next week where we'll be talking about advanced functions. So we'll dive more into scopes and probably recover some of what we covered here, as well as some more advanced topics. But I do just want to say before you jump into the exercises that it's okay if you don't understand everything we talked about here today. This is probably a topic that's going to take a little while before it completely gels. So yeah, I guess dive into the exercises and just start seeing how it works. And if you have any questions, feel free to reach out to us on Slack. All right, with that, I'm going to go ahead and end the meeting, and we'll meet back here about 10 minutes before class ends.